What do you remember about trig ratios? Absolutely nothing. Okay, what are trig ratios good for?
Finding other angles.
Okay, we'll start with Aaron. Okay, it's good to find angle measurements. That's good. Okay, I like that part. And what is there's a special. When do you use trig? What kind of shape? Any triangle? Right triangles, absolutely. Okay. And what was my next question going to be? When you're finding the angle, okay, so that's my symbol for theta, right? And how do you find the angle? Like in the calculator, there's a special button you have to do to find the angle. Anybody remember that one? That would be a very smart thing to do, to look at the calculator.
Second angle, please.
Second what?
Angle.
Sorry, Stormtrooper.
Maybe not.
Look at your sign. What's above it?
Sign to the negative.
Sign to the negative first. That's the one that you use to find your angle measure. Okay, so you use your trig function to the negative first. Okay. What else can we use trig ratios for in terms of the triangle? What else can we find?
Can't you do lengths of sides?
Yeah, that's exactly what you use. It's the other thing you use for your side lengths. Okay, and that's where you use just the trig button. All right, remember all that stuff? Is this ringing bells a little bit?
Yeah.
Half of it? Okay, that's all right.
It's like a 1 o'clock bell where it kind of goes just
1 o'clock bell.
What is in the corner of these sides?
This one or this one? Or this?
In the corner, yeah, this is.
90-degree angle. Okay. All right. There are 3 different trig functions. And we use the SohCahToa to help us keep track of what our ratios were, right? So let's start with, you want to start with the so or go down?
So.
Okay, so go down to the bottom of the page. Okay, and where we get the SohCahToa is because your S stands for what? The sine. Absolutely. And then what's the O stand for?
Opposite.
I think I want to just, stands for your opposite side. And then the H stands for your hypotenuse, right? Okay, so if I have, let's say my angle measure is, give me an angle measure.
30.
Huh? 30. And this side is what?
Right.
No,
Oh.
degree, not angle measure, but a side length. Sure, 10. Let's find the hypotenuse. All right. So I know my 30. This is my theta. So I replace the angle measure with the 30. My opposite is 10. My hypotenuse is the x. Agreed? All right, so how are you going to solve for that and find x? No. Yeah, if you multiply, think of it as cross multiplying, because then that cancels. But then you have to divide by the sine of 30. And so x is going to equal 10 divided by the sine of 30. And then what do you do? Yeah, plug and chug. So 10 divided by the sine of 30 gives me x equaling 20. Is that ringing bells? Move that up higher.
What's that? It's 20.
All right, good. All right, cosine. Cosine is the other one that uses the hypotenuse, except it uses the side adjacent to it instead of opposite. And so I have, let's do a different color so it's not the same. So we have adjacent over the hypotenuse. Oops, wrong color. So this time, let's say I know that my hypotenuse is, give me a number.
12.
Okay. And my adjacent is gotta be less than 12. Why is it less than 12?
Because the hypotenuse is the biggest side.
Because the hypotenuse is the biggest, so give me a number, huh? 7. All right. So I know adjacent and hypotenuse. That means that I'm looking for the cosine of theta. So I'm looking for theta, and it's equal to 7 over 12. All right. How do you plug that into the calculator? Because remember, I'm looking for the angle measure. So which button do I use? Yeah, you're doing your inverse button. So you literally press the cosine negative first, and then just 7/12. And so I hit my second cosine, 7/12. And I have an angle measure of 54.31. Okay, now, good question. How did I not get that same number? If you're on a graphing calculator, you need to check your mode and make sure you are in degree mode. If you're in radian mode, it's not going to give you degrees.
Thank you.
You're welcome. The mode button right there. All right, and the last one, TOA. TOA is our tangent. Okay. And it is the only one that doesn't use the hypotenuse. It is just your opposite over your adjacent. Okay? To me, this is the one that is the most useful because it has a lot to do with more of the real life things that are going on. And honestly, does anyone know how they started trig or where any of this came from and how?
Person way back in the day.
Say what?
Some old person way back in the day.
An old and brilliant person back in the day, actually like BC. And the trig started out when they were doing the calendar because they were trying to measure the distance from the earth to the sun, because it's not like you can take a tape measure and measure that, but they were trying to calculate to determine the seasons, which is how we ended up with the calendar, because they were trying to figure out growing seasons so that they wouldn't starve to death. Necessity brings you math. Anyway, alrighty, so let's say we have, give me an angle measure.
72.
Right, we have an angle measure of 72, and I know that the adjacent is, give me a number.
3.
Bigger than 3.
6. 27.
6 is good, that's fine. Alright, and we're looking for the opposite. So that means that I would have the tangent of 72 is equal to x over my adjacent. Everybody with me so far?
So, what are we solving for?
X,
But which side on the
opposite.
two sides?
You're good. Okay. So if I cross multiply or multiply both by 6, x the 6's cancel out, and so x is just this. I have 6 tan 72. And you literally don't have anything else to do but plug 6 tan 72, and x is 18.47. Easy peasy. 18.47. Is this starting to slowly come back to you?
Yeah.
Huh?
Do you always round it every time?
I round it to 2 decimal places just out of habit. It's a matter of what you need it for, and if it's, in directions, whatever they say.
Okay.
I always just do 2 decimals. All right, so we're going to do a little review or practice with Jack Sparrow, Captain Jack. Need help to escape from Port Royal. In order to reach Tortuga, you have to defeat all of the ships. All right, and we are in the submarine. If you complete all the problems correctly to successfully escape the ships, and safely reach the islands. All answers should include a diagram. All right, that's really the most important part. But let's talk about what all we have going on here. All right. Hi there. How are you today?
On the submarine?
Good. Thanks for your help this morning. No, it's fine. And this has been that kind of week. I know. I don't know how, yeah, it's all good. Good. Alrighty, I will send him down right now. Thanks. Bye-bye. Jason! Not you. The other one. Your dad's here. Okay, so let's talk about our pirate here. Okay, now we're in the submarine, and we're trying to go underneath the ships to avoid them. All right, and so let's talk about different words that would be in the word problem. The distance down is going to be my depth, right? Okay. What would the, like, how could I describe, in terms of my submarine, this distance to the ship? Any ideas? Yeah. If I'm on my and I'm on the submarine and I'm down here, how am I going to know where the ship is? What do I use to look around?
Your little scope.
The periscope, yeah, because my little periscope would come up, and then I could say, there's the ship. So we're going to call that the periscope distance. Huh? No. Sounded good to me. All right. Now, how can I describe my hypotenuse? Between the sub and the ship. Ooh, you could call it the shooting distance. Or you could we can consider it our underwater distance too.
I like shooting.
Yeah, I know. That sounds a lot more fun, okay? Because you know we're going to shoot at them. All right, so if this is my theta, what can I call that position? If this is my theta, what could I call this position? Because I'm doing an angle, so it's going to be an angle. No, how about my shooting angle? Because if I'm standing there, the position that I have aimed at the boat is going to be my shooting angle. And let's see, last but not least, how could I describe this angle? If you're on the ship and you're getting shot at, what do you yell?
SOS.
Huh? Not SOS. Incoming! So that's going to be my incoming angle. Well, just in case, we're going to just try and avoid them. But in case, because I want to escape safely.
Well, I can't shoot down into the water.
Wait, so we used to draw the second one?
So, the 6 problems, you're going to want to, you don't necessarily have to draw the submarine and the boat, but you definitely will want to draw a triangle. All right? 6 problems. Good? Questions?